Welcome back to episode 5 of the Inflatable Vehicle project. Before we get started with the outdoor testing of the structure, let me just show you what's new. Let's take it from the front to the back. And in the front I have added a battery, which is of course removable, which gives power to the PWM system controlling the two vacuum cleaner motors. It's the same kind of hack which I have made for the traction motors. And I've added a footrest which greatly increases comfort when sitting on the vehicle, and it was necessary to add grip tape because this plywood surface became super slippery when I had a little bit of snow under my shoes. And this knob controls the power to the vacuum cleaner motors. So I will show you later on, it goes straight down to the trigger, the same trigger as these ones. So it simply pushes down on a trigger like that. And I added a main circuit breaker as well. If anything goes really wrong, I want to be able to shut off the battery connection to the vehicle. And just for this time, I've added a selfie stick here to the control handle so that I can give you an interesting view when I'm trying to drive this for the first time, since last time was not that successful. And in the back I removed the central belt which keeps the whole seating in tension and replaced it with two belts instead. I want to have a more rigid seating, so this goes around the rear axle here. So here you can see the battery pack again, and it has a wire coming out from it. It goes directly to the trigger that I pulled out from the cordless drill, and the yellow knob simply pushes down more or less on this original trigger here. So it's a super analog hack, but the screwing action makes it possible to fine-tune the power setting, which is a good thing. And here's the main circuit breaker. It looks like a doomsday button, but it has the opposite effect. I turn it off when I hit it, so that's good. Okay, so let's get on with the second attempt to make this huge vehicle run. So it has been snowing quite a lot since previous test. You can see the two axles laying here with their wheels, but I think the snow is just a bonus, so let's get started. Needless to say, I really need to work out the system to assemble this vehicle easier. It's just unnecessarily difficult. It's a too tight fit on some parts, and I have some other obstacles I have to deal with as well. But here it is, and before I start inflating it, let's take a walk around and look at it. The grip tape really did its work. It was a lot easier keeping myself upright while I'm standing on it this time. And as you can see, the oven plate there is still a part of the vehicle temporarily to keep the battery in place. The vacuum cleaners does not suck air from beneath. They suck air from all these holes passing through the cooling fins for the transistors. So I don't think it's a problem that the vacuum cleaners are almost submerged in snow. So now I only have to connect my control handle to this one and the battery, of course. And I also need to tighten these nuts. I forgot to bring a tool for that. I'm thinking about 3D printing a handle later on, or perhaps do without these to make the assembly process easier and have some sort of tension system built into the mainframe here, which I hope will make assembly a lot easier. So this time I decided to try and inflate it at the lowest power setting. So I have been inflating it at about 1 amp, and the battery is 5.2 amps. So it's a pretty conservative current draw on the inflation stage. But it took a long time, like 20-25 minutes. So I don't think it's much gain in going so low in power when inflating it. But here it is, ready again for hopefully a more successful test drive. So I'm just about to try out the traction system and try to make it move. Okay, so there goes another transistor, and this time it was really my fault. I should have thought this through a little bit more before doing this test. The previous tests mishap where I had a mismatch between my DIY PWM circuit controlling the vacuum cleaners and the traction motors ready-made PWM circuit. This was more difficult to foresee. Now I've changed this one to yet another of these ones. So now I have 3 of these circuits running in parallel, and they work fine together. But this time I really should have just made some basic measurements when I was dimensioning my transistor array for powering the traction motors. So what I should have done is that I should simply measure the resistance of my traction motors. And if I measure the resistance of this 600 watt angle grinder, I can see that the resistance of that is around 11 ohms. And if I take my more powerful vacuum cleaner, this old vacuum cleaner, it's 1400 watt motor, and if I measure the resistance of that, I can see that it's around 5 ohms, which means that to be certain that the power stage, the transistors can handle the stall current, I simply have to divide my peak voltage, which is 268 volts, perhaps say 270 when the battery pack is fresh of the charger, with the resistance in my traction motors. And the resistance of those even slightly more powerful than the vacuum cleaners, the resistance is 3.5 ohms. So I take 270 divided by 3.5 ohms, I get 77 amps would rush in when the motors are stalled. And these can take 23 amps each. So obviously significantly underrated, because I only used one of these for each wheel. So I had to redesign that stage. So I'm thinking about adding up to perhaps up to 5 of these transistors. So I have well over 100 amps rating. So simply I will burn the motors before I burn my transistor stage this time around. So I will do that. But that's kind of silly. This one, I want to measure the resistance on this machine, but it has some electronics in it which prevents me from doing this simple measurement. I have to open it up to do that. But basically, the more powerful motor, the lower the resistance will be in the windings, and the more powerful, of course, the more fiercely dimensioned power stage you need to have. So I'm going to do that for next time, but I felt I was so close. And the reason for me to at all believe that it might work to have a single of these transistors chopping the power to the motor is that I'm actually using one of these to power both vacuum cleaner motors, and they are 1000 watt each, so 2000 watt of power is chopped by one of these. But the thing is, a vacuum cleaner's rotating assembly is very light. It's just the rotor and a small radial fan, so as soon as the current rushes into the motor, it starts spinning almost instantly and pushes back the current, so that you don't have a short circuit situation for more than a couple of thousand of a second. And these can take higher currents than the rated 23-24 amps if it's just a couple of thousand of seconds. So so this works well with the vacuum cleaners, although it's kind of under-dimensioned. But in the traction system, where the motors might be stalled for a while or have very high load during acceleration, or like in this sequence when I'm starting to spin the vehicle around its vertical axis, there's a lot of, it's almost like the motors are short circuit under a longer period of time. So I simply think I just overloaded the single transistor on the rear left wheel that started spinning like crazy, and that would be their typical failure mode, that they get short circuit. So that's why you need to have the doomsday turning off button on the vehicle, because if they fail, the vehicle might just go full throttle. Okay, so that's next for the next test to build these significantly more powerful stages for the transistors. All you have to do now is to stay tuned, and we will see if the third attempt is like the third time is a charm, right? And again, if you like the content, please consider subscribing, and I will see you next time.